My name is Dr. Russell D. Young, and my job title is Senior Research Scientist in the Science Directorate of NASA Langley Research Center here in Hampton, Virginia. I got involved with NASA when I graduated from the University of Illinois a long time ago, and they hired me right out of graduate school to start a new project in nuclear pump lasers in space. Trying to use a nuclear reactor to pump a laser, beam this energy across space to multiple stations where that would be converted into electricity for many uses. And then later I was involved with solar pump lasers to do the same thing, and more recently worked in the Science Directorate to develop instruments, LiDAR instruments in particular, to analyze the atmosphere, to measure the profile of gases like ozone and aerosols and water vapor. And while working here, I participated in a number of projects, specifically laboratory research, building advanced instruments, LiDAR instruments to measure different constituents in the atmosphere. And been doing that for quite a number of years, and enjoyed working with LiDAR and lasers, but my whole career has been working with lasers in different applications across the spectrum of needs, but most recently the atmospheric science need. The most exciting aspect of my job is working with students. I enjoy working with students a lot, helping them get graduate and PhD degrees and master's degrees, and also high school students come in during the summer and work with me in the lab, and we have a wonderful time together. And I also enjoy working in the lab. I like to be hands-on with instrument development, particularly LiDAR instruments, and currently we're developing a water vapor LiDAR, which is very small and compact and can be used in a number of situations around the country to measure the water vapor in the atmosphere, which has an important element of measuring what's the water content, because that determines the weather that we are so concerned about on a daily basis. So if you know the water vapor distribution in the atmosphere everywhere, you can more accurately determine weather patterns. And the lessons I've learned in school that apply to my job are that you have to be multifaceted. You have to take physics and chemistry and engineering and math and apply them across the board to these problems, because no one discipline or no one major can be applied to all the wide breadth of problems that we face. We have to be multifaceted in terms of our background and education. So it's important to get a broad education in chemistry, physics, math, and science. And with that, you can solve the pressing problems that we face today.